Welcome to Micrel's online design tool, MicrelSim. In this video, we will provide an overview of the electrical simulation tool using a buck regulator. Coming to Micrel's main web page, we see two widgets, one for thermal simulation and one for electrical simulation. I want to do a buck, and I want 12 volts in, 3.3 volts out, with an output current of 10 amps. Note you can also access MicrelSim on the right here on the quick link. Now I'll find a solution. If you don't have an account, select Register Now link and provide the necessary information. If you have an account, enter your username, which is usually an email, and your password. And select Login. We are now in the dashboard where we can easily compare and make our product selection. Our IC type has been pre-populated as step-down buck. Our input's 12 volts, output 3.3 volts, and the output current is 10 amps. You can also filter on additional features. The 30 plus parts have been filtered down to 9. I can further reduce by, let's say I want the parts that are $3. So I click that and I can compare the details. Now I can look at them vertically and I can see what looks most interesting to me. I see that the thermal resistance on this 5x6 here is 28. It's low. I like that, so I want to click the MIC 261201. I'm in the design requirements part of the tool. I recheck my input requirements, 12 volts. This is plus or minus 20%. I-out's 10 amps, V-out's 3.3 volts. I create the design. What's happening now is a schematic is being generated that will calculate all of the components according to my design requirements. Now I come into the schematic. The components in blue you can edit. Here I can change the inductance or the series resistance. You can perform various simulations, AC analysis, transient analysis, steady state analysis, and startup analysis. The wrenches on the left, you can adjust the span. In this one here, you can adjust the frequency span. Here's the time span. I like to do transient analysis, so let's put a heavy load on here. So I'll go from 1 amp to 8 amps. And I will run the load transient. It's calculating using Simplest. Doesn't take too long. Simulation successful. You see we have different views of the part: input, IC, switching, and here's the output. And you see the output. This is the voltage scale is a zoomed in version. We've got 3.35 here at the max here. You can actually use the cursors here. And I'm looking at the top. And I'll take the cursor here, bring it over here, and look at the top. And you can see that we went from 3.342 down to 3.11. This is a very heavy load, 1 to 8 amps. And here within a tenth of a millisecond, you're back up to pretty much where you were with the additional load. I like to go to the output, put all of them on here, and then I can X out this and look at just what I want to get a close-up of. Here's the load transient, and you can see, with this scale here, it's just barely a blip. And let's look at the switching node here, and I can zoom in here as much as I want. Let's look at that. Okay, oh, I can also zoom out if I zoomed in a little too close by hitting this sort of go back button. Let me just take a little bit more here. And you can see that the off time varies here when the load goes up. You can see how it's controlling, and it gives you a lot of insight into how the part works. You can investigate various scenarios with the simulator. Let's go back and look at the BOM. Here we see a parts list. It's a generic one. We also have arrow, digikey, chip 1 stop. Next to the part numbers, you have this little sheet of paper with a magnifying glass. And what this does is it gives you alternative part numbers that you could search. Instead of AVX, I could use another part. Let's say I want to use Chemet instead, and then apply my filter. So I have Chemet capacitors, and I could change that in there. You see C2 is now a Chemet part. This helps a lot with your BOMs. So let's move to the summary. In the summary, we have the operating conditions that we did the design with. We have our configured schematic, all of our results for simulations. We just ran the transient simulation. The bill of materials, you'll notice there's an Excel download. And if you come back up to the top here, you'll see a PDF of the summary. Once I've finished the design, I can save it, put a name in, comment if I'd like, save it, and once I save it, I can share it. I can put an email in of a colleague. I can give them read or read-write privileges, and I can send an invite. Finally, the final topic I want to bring up is the feedback button. Give us your feedback so we can improve the tool and make your design experience even more fruitful. Thank you for watching.